Good evening, everyone. My name is Avinash. I'm a second year doctoral candidate at TU Eindhoven. I am from Information Systems for the Built Environment Group from Eindhoven. Today, we are I'm presenting our work on unified application interfaces. So it's a idea of abstraction that we are doing in the asset management practice, particularly for smart building contexts. The main problem is that for the current digital twin practices, we have different building systems, and each system and the digital twin has to communicate with each building system in a point-to-point way of communication. But there is an inherent challenge that the asset information source is distributed or fragmented. Meaning for the structural or any kind of subsystems, there is a separate information source. And the second challenge is that this asset information is not managed by one single company or a building owner. So this is also it's managed by multiple vendors. And so to address this challenge, we have come up with a concept called unified interfaces, and this is a kind of layer of it's an abstraction layer that abstracts the entire data exchange or data retrieval from the individual subsystems. So to define what is in unified interface, it's a standardized access layer which again abstracts the heterogeneous building systems. And the main agent or the main idea is to provide consistent information flow between systems. And like when we say standardized access, we are trying to standardize the response or information for asset type. Meaning for a structural asset, you have one standardized way of retrieving information. Again, heterogeneous is same. Consistent asset-centric. So when we say asset-centric is also a way of retrieving information. Right now, we are all retrieving information from a system point of view. But when it is asset-centric, you exclude or we eliminate the boundaries of whether it's coming from BIM system or BMS system or it's from FM system. So that it's a different approach to information processing. And I think this was adjusted, but in my slides. But unified response, meaning you have the asset metadata, and the response is coming from different layers of the system. So one of the main feature when I say unified interfacing, it's not just one single API endpoint that gives the entire information. So it can be orchestrated endpoint that talks to multiple systems and retrieve information from the multiple systems. And the biggest advantage is it should be or the idea is that it should be vendor agnostic, meaning whether it's I have a BMS system with different identifier. So the unified interfacing will assume that the original sources are there in place, and it only abstracts or it only retrieves information based on from the each different schemas, or it can work with different schemas. This was also another point that I was talking the previous presenter Flavio. So when we say integration, there are two types. You can also integrate at data level, and the idea that we are proposing is to integrate at system level, where we don't want to duplicate the original sources, and but there is always constant sync between the original source and the current system level source. Main important thing is web-based access, even for the static information sources like BIM or Excel files. So we want to convert them into web-based information sources, like converting them to RDFs or SQL, and then access that information. And final thing, of course, this has to be extended. So if I replace my existing vendor and come up with a new facility management vendor, I can just use this. The system can function as it is as a whole. To put it simply, the idea is to right now for asset managers, if I have to find out maybe for the asset information, maybe sensor asset information for this particular space, they have to first retrieve the HVAC data from BMS system, and then they have to get the maintenance history from the maintenance management or facility management system, and then geometric information from BIM. Instead, we are providing a unified endpoint where it is not necessary that, of course, for the context of this paper, we are talking about information retrieval, but there can be multiple API endpoints which can unify data. So, if I have to find information from AHU1 about AHU101, I can just use this unified interface endpoint, then get the information. But to have this in place, there is a missing piece, and that missing piece is that because individual systems store information on their own, and a BMS system will not know the information about the same asset in the BIM model. So, there is a discrepancy or inconsistency in the way we store information, and this leads to, in the current practice, this leads to point-to-point integrations or pairwise integrations. So, we always have to integrate BIM with BMS, BIM with FM. So, there is a lot of pairwise integrations. Instead, we are proposing a mapping layer, which is a graph-based mapping layer, where we for in the example, it says that room a temperature sensor with a given ID is located in an IFC space 602, and the AHU is located in 602. So this is actually trying to map the link between the same asset in different systems. So as per the final asset management system will look like this, where we have a GraphDB for mapping layer, which will also be and we want this system to be managed by the building owner and not by any other vendor. But in practice, this can also be managed by some external vendor or service provider. So far, we have done an implementation of this in a Spain building. I am part of a project called Wilson, and we have demonstration sites in multiple 4 demonstration sites in different countries. So it's a office building in Spain. This digital twin UI of how it's basically a model loaded in web. And we try to study BIM and space and sensor assets, basically BIM and IoT systems. And the space information is stored in RDF. Sensor system is the time series data is there in MongoDB, and the mapping is there in RDF. So if you see that we have system specific endpoints and also asset-centric endpoints that we have developed for this. As we say, the information is distributed. So this is the asset mapping that we have done for the Spain building or a demonstrator building, where we have a temperature sensor. It is same. So for a single space, we have 3 different temperature, CO2 and luminosity light sensors. And in the graph, we can also see that there is a clear segregation that the entire RDF is from the BIM model and the Mongo time series. This information, I am not even storing any time series data in the graph. It is just a mapping layer. So we are trying to link that or create the links between 2 different systems. So for asset manager, when he requests for sensor asset information for a particular asset, the request will go to unified asset interface, and there is this option of include in the request. So when they include the request, you get additional context for that particular asset that they are that is in query. Else and then it retrieves, uses the mapping knowledge graph to get the related assets or relevant asset information. Else it will directly talk to the building systems. So this is a sample request and response, where if I include use the keywords include, then I can get the associated assets classes, and I can get that context in the response. So we have validated this in 2 deployment context. So in the local deployment, we see that because when instead of using system-centric endpoints, if you are using a unified interface, there is a not a significant difference in the API response time, but because 41 seconds is it's an average API response time that we found, which is slightly higher because of the orchestration process between multiple systems. And for comparison, for apples to apple comparison, we did it in the cloud deployment where we have used retrieved same information, getting sensor data from and the system centric API, and getting sensor asset from the unified interface. Then we did not see much difference in the API response time. Yes. This brings to conclusions that the asset centric, it is important, and it simplifies the information access from heterogeneous information sources for the smart buildings, particularly web based access. So we use web based protocols or web based APIs like RESTful. And the other big advantage of using mapping layer is that even when I replace a system or existing service provider, I don't have to worry about how I can integrate with multiple systems. If I can update the mapping layer, then I can your system will continue to work. Information consistency. We aimed at getting consistent information without duplicating data. Acceptable response time, that's a trade-off that we are getting. With slightly higher response times, you get more context. That's all. Thank you. Yeah.
But would it actually possible to build this map